So, welcome everyone in Efficient Kotlin. This is a presentation based on my book, Effective Kotlin. That is a general best practices book. I will concentrate on the third part of this book that is dedicated to efficiency. So, how to make your code faster, more efficient, use less resources. And without further ado, because our time is short, let's start with general best practices. And I would like to start with a concept that we use every day. That is a concept of an object. So, object is something that we use pretty often, and many people are not aware of the costs that comes with objects. They reveal it themselves only in characteristic situations. But it's good to have awareness of those costs. So first of all, each object needs a header. Header tells us what the object is, where it is, etc. And this header weighs 8 or 12 bytes in our memory. 8 or 12 bytes, very little. It also needs a reference, 4 or 8 bytes. This is in general, those are very small numbers. But now if you compare a primitive int that weighs 4 bytes, and you compare it to an integer that is a wrap type that weighs 16 bytes plus reference that is like 5 or 6 times more, then you can see 5 or 6 times can make a difference when you have plenty of integers. So it reveals itself only in a characteristic situation. And it's good to be aware that this difference can get visible in some situations, okay? Objects need to be allocated. Allocation time is a very small thing, but still a thing. And when we allocate an object, we need to allocate its state. And we'll see that this also can be optimized in different ways. Also, methods, functions, our most basic abstraction in programming, it has its costs as well. We'll get there. So the first thing is to limit the number of unnecessary objects. Basically, perfectly to not create unnecessary objects. And there are a few ways how we can do that. I will start with a very simple rule. Imagine that you need to implement a linked list that has a node with a value and a reference to the next element, and an empty object. The problem with this class is that we create this empty object every time we need it. And, small cost, but still a cost. Instead, we could use an object declaration, and with that, we have one empty used everywhere. Notice that this needs some tricks with generics. It's better described in the book, but we need to use covariance and nothing type to be able to make this empty object a subtype of all the collections. That's also a very popular practice. This practice is used when you pass messages, we use objects instead of classes when there are no values inside. It is used on many layers on libraries or some programs. So for instance, if you take a look at the standard library, you can find an empty list there. That is an object declaration. There is one empty list for your whole program, basically. And that's this optimization. Another rule, and I believe this is the most important optimization, especially on backend, but also on frontend, is to use cache. And cache, by definition, is a redundant memory. So a memory that if you delete it completely, nothing is lost, because it's redundant. For instance, you can place a cache before asking for a database so that in cases where something is in this case, you do not need to ask a database and it is faster this way. Sorry, I spoiled one of my questions, but I have another one. So cache is used on many different layers on JVM. The very popular usage is that an integer values, the wrapped values, have a cache, so they are not created in some range of numbers. And now I have a question to you. What's this range of numbers? Do you remember that? What's the range of numbers for which you do not need to create an wrapped type out of an integer type in JVM. Hands up.
So it's minus 127 up to 128.
Close, but not.
Oh.
Anyone? So speak it up. he put a hand first, so please stay with me. Minus 128 to 127, and it's like 0 is included into positives, so please stay with me. We can use cache on many different layers. JVM, everything uses cache on different layers. Computer has caches on many, many layers. Your network has caches everywhere, on basically everywhere. We can implement a simple cache with a map. Of course, this is a trading performance for memory. We are buying performance for memory. So instead, it is much better to implement a better cache. Best if it uses a soft reference, so that when your memory is nearly out, then it's freeing those caches, because cache is redundant anyway. But it's of course best to use caches from well-implemented libraries. You can surely find those kind of libraries. And of course, with cache, finding out something for the first time is slower, but finding it for the next time is immediate. Okay, another important technique is object lifting, and I will start with an example. So imagine that you need to find how many there are instances of the biggest value in a collection, and this is a simple implementation, but it is very bad. And what's the problem, and what is the solution to this problem in this example? Please, hands up. Oh, one more rule. If someone answered the question and I said it's right, then please do not, put your hand up again.
You're calling max or null every time?
Yes. And what's the solution?
Lift max or null out of.
Perfect. So stay with me. In the first example, we have an n² complexity. In the second one, we have a linear complexity. So it's much better solution. Another example, imagine that you need to find out if a string represents a valid IP address, and what's wrong with this function implementation. The little helpers of mine need to figure out who was first.
You're parsing the regex every time.
Exactly, and the solution?
The solution is to use pattern parse or something to compile the regex before and save as a static field or a
Great.
object.
So this is a solution, one solution. Perfect. Stay with me. But this is not. No, it's not the perfect solution, because we are trading one problem for another. So, can anyone see what's still wrong with this code? You have someone in the only hand I see is in the first row.
The regular expression doesn't appear to be static, so you're basically compiling it every time you're instantiating a string.
It is a static value because it's a top-level property.
Well then, I have no idea.
So imagine that you have many functions like this one in a single file, yeah? And when they are instantiated, so when you need the first one out of this file, and any function from this file, you need to instantiate them all. And those are heavy objects, many of heavy objects. So this is heavy, and this can, be visible on a small but annoying, performance problems. Like when you're starting your unit test, they should be immediate, but instead they need to instantiate all the things they do not need, and it makes them the instantiation slower. And the nice solution to this problem is to use a lazy delegate. It's one of the solutions, but it's used on different libraries. Okay, the next item I would like to describe is to use inline modifier. If you go back in like 10 years back, the functions were, in Java, the way how we process collections was still pretty primitive, because to introduce a modern collection processing, we need to use functions as objects. And Java community opposed that for a very long time. And a popular argument is that it is because it is a cost, a performance cost. For instance, imagine that you are using a for each function instead of a for loop. For each function uses for loop under the hood. But when you are calling a function, you need to jump with your execution, store your local variables and the jump back address on the stack trace, and jump there, and after that, restore everything. This is a cost, a small one, but still a cost, okay? And it costs something. It is much worse when you do that for every single item in your collection, yeah? So every lambda expression is a form of boundary that needs to be passed when you use that. Can you see it? It's even worse when you are capturing some variables. Java does not support capturing local variables, so they need to be wrapped into objects, and whenever you access them, they need to be, there are boundaries that needs to be passed. And those costs add up in a bigger collections, and they start being visible. And this was one of the arguments why this, way of operating on collections is not good. But Kotlin found a remedy to that, a very simple remedy. So the remedy is to use an inline modifier. When you use an inline modifier, then such functions are not really called like regular functions. Instead, during compilation, their calls are replaced with their bodies. And the calls of the lambda expressions inside are replaced with the bodies of those lambda expressions. And this way, we have a cake and we eat it too. We have performance and we have readability and functional style. So that's why we use inline modifier for functions with parameters of functional types. It's not the only reason to use inline modifier. Inline modifier is very powerful because it allows reified type parameters. Java loses types. That's why you cannot check if something is list of int, because under the hood it's just a list. The same when you pass a type into a function, you cannot get its reference because this type is lost. But if you use an inline modifier, you can make your type reified, and then you can reference its class. Why? Because under the hood, the usage is replaced with the body, and the type exists. It's a very great power of the reified parameter. Okay. Of course, inline modifier has its costs as well, so it cannot be recursive for obvious reasons. We cannot use elements of a more restrictive visibility in inline functions. It's because if they would be inlined in the context that cannot see them, then your code would not work. That's also quite clear, and that's the biggest restriction. That's why it's basically useless for an OOP. Inline modifier is practically only used for helper functions and redundant functions on libraries, and it makes your code grow. What is a small problem, but still something. Okay, Now I would like to tell you a story that happened in USA. NASA wanted to say a Mars orbiter, I believe to research Mars atmosphere. And like many companies, they outsourced their software development. And I believe that the software that was created was actually a very good software. It was probably well tested, well implemented, etc., etc. But apparently there was some miscommunication between NASA and this company, because NASA was using European unit of measures, Newton seconds, where the company decided, maybe they thought, hey, we are in America, we should use American strange units of measures. They use pound for seconds, and you know, it's hard to talk in different languages. So whenever the software started, orbiter nearly immediately crashed into the atmosphere, in this simple way, burning over 300 million of US dollars that were, you know, worth a bit more than they are today. Okay, so that's lots of money burned. I hope we at least learned something from this experience. One thing that we've learned, that indicating units of measure is quite important because mistakes can be quite costly. And how do we indicate units of measure? So let's imagine a simple API that accepts a time. So what is this time? We don't know. It's not clear at all. You can read documentation, but nobody does that. So it's not very safe to implement it this way. A simple, not very safe, but a simple improvement could be to use a unit of measure in the parameter. So you could name it time millis. It's not very safe, but it is an improvement. Also notice it's not very helpful for the result type. So if you have a result type, like decide about time, what is this time? Let's say it's minutes. It's not indicated in any way. We use minutes as milliseconds, kaboom, you know? We crushed another millions of dollars. So how can we improve it? And a common solution is to use objects. It's the safest solution. I hope you know that using type aliases is not a good solution because it does not give us any degree of safety. It's only adding additional risk. Using classes is a good solution because it forces us to transform the type when the type is not matching. So you are forced to transform it into a correct type in here. Okay? But we traded safety problems with we solved safety problems, but in expense of creating unnecessary objects. And how can we solve it? Maybe actually I will make an extra question. How can we solve this problem? It's a more recent solution. It was introduced a few versions ago and modified quite recently, but seems to be quite stable right now.
Operators overloading?
No, it's not what I mean. It's not very helpful, I believe. Anyone?
We could use a value class.
Yes. More concretely, inline value class. It used to be an inline class, but in more recent versions, Kotlin introduced value classes. In JVM, you should also use this annotation JVM inline. When you use that, then during compilation, your wrap type and name is replaced with the thing that it wraps over, a string in this case. So, name is gone. All its methods are replaced with static functions, so we eliminated the cost of creating an unnecessary object. beware, it does not work if you use objects from behind the interfaces or superclasses. So it only works in simple cases. I had a slide for that, but I wanted to skip it to concentrate on other things. Oh. So yeah, so here you can see that I apply this rule. So I create those inline value classes, and I use them so I have 100% safety, and it does not cost me, it costs me practically nothing, only a bit in compilation time. It is also useful when you define some entities. So on entities or documents, you need to define values with primitives like int, string, etc. So it's easy to make a mistake, to use teacher ID as a school ID or student ID, maybe because of an accidental reorganization or maybe because of something else. A simple solution is to also use a wrap type, but when you use JVM inline value classes, then it will be seen by the library as a int in this case, and at the same time you have full safety. The next rule that I would like to mention is to eliminate obsolete object references. And I believe we have quite a few Android developers in here. I guess we have quite a few Android developers in here. Every youngster Android developer, including myself, did that at least once in his or her life. Oh, sorry. I forgot about the introduction. So in Java, in Kotlin, we rarely need to think about managing our memory. It is because we have this guy. This is a garbage collector. He is managing memory for us, but we should not make his life harder than it is already, because we pretty often make mistakes and we point to references that are not needed anymore, and by that we are achieving something called a memory leak. A reference that is not needed, but it is blocking memory from being cleaned, and that is a very problematic situation. So I mentioned this Android problem. This is how it looks like. Pretty often Android developers, youngster Android developers do something like that. They define some activity. Activity is like a window in Android. It's a very heavy object, but since it's needed in many places, they store it on some static property like companion object activity property. Yeah? When they store it in a companion object property, it cannot be garbage collected. Even when this activity does not exist, you exited that, you can forget about that. Garbage collector, our system will remember about it, And it's not needed at all. And that's a very big problem. We are wasting memory, but it also leads to Android not working correctly with this object. Okay? And this clearly bad practice should be. We should not do it this way. But when people learn about that, they are often looking for different ways how to do exactly the same thing, but in a way that it is not so obvious. And for instance, I could find examples like this one. People storing a reference to a lambda expression that prints log messages. The only problem in here is that, notice this lambda reference is capturing this. And this is a reference to the activity. So when you store this lambda reference, you are storing reference to activity. So you are still having activity leak. It's just hidden. So it's even worse memory leak than before. Does it make sense? Okay, another examples and a question from my side. So this is inspired by effective Java. Here we have a stack where we can push values or pop values, and the question to you is, what's wrong with this stack? and how to fix it.
So I need another second, but I think that you do not lose memory in POP.
And can you explain how so?
Yeah, so when you push some element and you have more and more elements in the array, when you're removing these elements, the allocation of memory will be the same as before. Yeah?
Okay, and any ideas how to solve it?
So probably you should have some check of the size and recreate new array.
Okay, stay with me anyway, but the simple solution is to set null. It's the most common way to free memory when we have some. So maybe a context in here. So imagine that we push 1,000 elements into this stack, yeah? And then we pop them all. But notice that without this setting, our stack is not modifying this elements array. So those values are still in this array, okay? They are still referenced. And so they are still kept alive by garbage collector. So how big of a cost it is? I don't know, it depends on what we keep in this array. It can be something expensive, you know? So that's a probably big problem. So the solution is to set null to clean up this array with objects that are not needed anymore. Okay? So another question and another challenge. Imagine that you need implement your own lazy delegate that creates value lazily when you need it for the first time. This is a working implementation. But there is an essential problem with this implementation, so with memory, of course. And can you tell me what's wrong in here? And how to solve it? Okay, sorry, but my time is limited, so we are used to. So notice that we have this initializer with a lambda expression. Yeah? Once we've created the object, the initializer is not needed. Okay, what is initializer? It's a lambda expression. How expensive a lambda expression is? We don't know. It depends on what it captures. It can be very heavy. It might, reference an activity or whatever else. See? So once it's not needed, once we initialized it, we should let it go. And we can let it go using, setting it to a null reference. And this is a better solution. So, noticing where something is not needed and releasing it, it's an important skill that is worth to be trained, because it's, it costs you very little to do that in terms of readability, but it can help a lot your memory. Hey, moving to the next section, efficient collection processing. As I mentioned before, collection processing is a very important part of basically development. Some languages were all created around collection processing. Lisp, the name Lisp comes from a Lisp processor. For years, collection processing was a selling point of functional programming. People were looking at functional programming and mainly looking at collection processing. This is what we want. No wonder why, not so long time ago, this is how a typical collection processing looked like in Java. This is how it looked like when Kotlin was still young. And Kotlin introduced collection processing functions that are known from functional languages like filter, sorted by, map, etc., that let us make it clear, concise, and readable. But we should also know a few tricks how to make it more efficient, and this is what this section is about. So the first thing we need to understand is the difference between iterable and sequence. They look practically identical, but they represent very different concepts, extremely different concepts. Iterable represents an object that we can iterate over, like a list or set, something physical, a collection, you know? Sequence is very different. Sequence is used to represent a set of operations to be done. Sequence is not a collection. Sequence is not holding anything. Sequence is just a definition of how something should be calculated. So sequence is conceptually much more similar to a lambda expression than it is to a collection, okay? And even though we can process them in nearly identical way, what happens under the hood is very different. So when you do iterable processing, like filter, map, etc., you create a new list or other collection ready to be used, okay? When you do a sequence processing, all the intermediate operations, the operations in the middle, are just a wrapping of the previous sequence, are decorating this sequence with new capabilities. So everything inside are intermediate operations, map, filter, everything that comes from sequence produces sequence. Everything happens in the last terminal operation. What is a significant difference. You should never store sequence, you should store collections. But in terms of processing, sequences have some advantages over collections, over longer processing, comparing to collections. And let's see them. So the first big difference is that when you do a bunch of operations, collections are eager. They are processing operation by operation. So they first filter all the elements, then they map all the elements, and then they do for each for all the elements. They're also allocating collections for each of this step, what is also a cost. Sequences operate element by element. They never think about more than one element at a time. So they first take one element, they filter, map for each. Then the second element, then the third element, filter, map for each. So thanks to that, if you do not need to use all your values, for sequences that are lazy, you will not. So if you need to first map and then find, when you use a list, then you will map all the elements and then find in the result. In use a sequence, you are first mapping first element, finding not, okay, mapping the second one, found it, perfect. That's it, okay? That's why sequences do the minimal number of operations, what collections by their nature cannot do. They can be infinite, exactly for the same reason, because they are not processing everything, they process the minimum possible values. They also are more memory efficient because they are not creating collections at every step. They always think about one element at a time. And in general, you can say that they are better for heavy, big collections. And I think a good example of that is when you process a file. So imagine that you have a big file, Chicago crimes. There are plenty of Chicago crimes. I believe this file is around 2 gigabytes of data right now. You can download it. It's published by the Chicago police. When you read lines, you have a list of all the lines. If the file takes 2 gigabytes of data, list of all the lines, more than 2 gigabytes of data. Then you drop. By doing drop, you create a copy, so another 2 gigabytes of data. Then you do map, another lots of data. Filter, another big collection. So you allocated plenty of memory. In some computers, it can lead to out-of-memory exception. On others, it will only make your garbage collector really, really angry because you are giving this garbage collector a lot of unnecessary work. A better solution is to use function useLines that operates on a sequence. Sequence only think about one line at a time. Once it's done with one line, it asks about another one, and this is much more efficient this way. So, my suggestion, prefer sequences for big collections with more than one processing steps. Those are characteristic situation. It's not everywhere. I do not suggest to use sequences everywhere, only where it makes sense, okay? In other cases, you can decide which one you prefer. Another rule was I've learned from the company I worked for. It's very popular in Allegro. It's a very powerful optimization to use, to associate elements into a map to optimize finding them. So imagine that you have a list of configurations and you very often need to find a configuration by its name. Okay? So if you use first or null or find, that's the same function, it's looking for configuration every time you need it. If this is a big list, it can cost a little bit to compare all those names. Yeah. So how it can be optimized? Very easy. You use function associateBy, so you create a map from a name into a configuration, and then finding element by name, bam, immediate. It's an O1 complexity. It's immediate operation. Yeah. Very popular optimization used on many different layers, wherever you need to find many elements, associate many elements from one collection to another. Another important optimization, maybe less important but still important optimization, is to use groupingBy. So when someone asked me to come and help him or her with collection processing, it turned out very often the function that this person was missing was groupBy. Very useful function. We use it to group elements by some property. We transform list of elements into a map from the key into a list of those elements. So for instance, if you have a list of users, but you need to count how many users you have in each city, easy. Group by city and then get users size. You have a list of players. You want to know how many points each team received. Easy. You take players, group by team. For each player, in each team, you sum their points. Easy. And that's nice function. Good to good to learn more about it. Good to practice that. But there is also a more optimal version of this function. It is groupingBy. GroupBy returns map. GroupingBy returns grouping. Grouping is just a pair of a key and elements, so it can optimize the processing of those elements. It's much harder to use because it has only few functions. I described them in the book, but you can do things like count each, to count the number of users in each city, or you can use reduce to count the number of points by each team. Okay. Another pretty obvious rule is to limit the number of operations. Kotlin introduced a lot of alternative functions for collection processing. So for instance, when you have the following processing, what can we replace it with? We also have someone in the first, and someone there, okay.
We can use map not null?
Map not null, perfectly. So instead of this filter and map, we can use filter not null. Instead of map and then filter not null, we can use map not null. Perfect, stay with me. I made a small table of those more efficient alternatives. Kotlin has lots of them, so it's good to learn about what options do we have for collection processing in Kotlin and use them efficiently. And of course, IntelliJ helps us a lot. Okay, one of the last items. This one is only for library creators and when you do something very performance critical, yeah? It's not for everyone. There is this suggestion that instead of list of wrap types, you can use an array of primitives. You already should have some idea why, So list of wrap types is much heavier. So if you have a list with 1,000 million integers, it should weigh around 20 megabytes of data. And if you have exactly the same, but array of primitives, it should weigh around 4 megabytes of data. Also, processing is faster for an obvious reason. When you use wrap types, you need to unpack them, pack them. A small cost, but everything adds up. It's not a huge difference, but still, it is a difference. So with this optimization, you can save some memory and you can save some processing time. But of course, it is a very, it is for a very specific use cases. And the last one is to use mutable collections, especially on a local scope. So if you add an element to a read-only collection, under the hood, it means creating mutable collection and adding first all the previous elements and then the new element. So you see it's definitely slower than just adding a new element into a mutable collection. Yeah? So in many places, it's better to use a mutable collection than read-only ones. But of course, there is a conflict of items because I started this book, The Effective Kotlin, with the item to limit mutability. And in general, immutable lists are easier to manage. You can more easily track their state, and in many ways they might be safer. And mutable, as you can see, can be more efficient. So there is a crash of items, crash of the first item and the last item, what was intentional, and you need to decide what is more important for you. But in general, when you are operating on a local scope, like in here, then it is definitely better to use mutable collections because we do not care about the advantages of read-only ones. Okay, and that is it. Everything is based on the effective Kotlin. For the sake of reference, this is the list of items. You can also find the chapters and the descriptions of that, I believe most or maybe even all that I presented on the KT Academy website. I publish them as articles, so you can just go there, KT Academy articles, and you can find practically all the items. On the website, you can also find my workshops where I teach that. Currently, the most popular workshops of mine is a Kotlin coroutines that is based on my other books. But advanced Kotlin or even effective Kotlin are popular as well, depending on what's your level and what are your needs. And I, of course, have different workshops. We are working with other trainers as well. For instance, we have I believe one of the best, or maybe, one of the best specialists on A/B testing with his very great workshop on A/B testing, and many great specialists that I can truly recommend. So this is the website, and that was everything from my side. Slides will be available on Twitter. Thank you for your attention, and I hope you will have an efficient Kotlin. Thank you. Those who I asked, please stay with me. And I don't know if okay. So tell me when I need to go out to not take the time of the next speaker. What problem type alias introduces in your... I had a slide for that. I can show it. The problem is that type alias does not allow us any safety, you know? So if you define a type alias that is representing minutes and representing milliseconds, you can use them interchangeably without any problems. What is a problem clearly? Here it is, yeah? I have type alias seconds, I have type alias milliseconds. Type alias is just like a nickname for something, an alternative name. During the compilation, all the type aliases are replaced with the actual type that stands, so seconds is replaced with int, millis is replaced with int, and all the safety is not working here. Have you tried the benchmark list for each in Java and Kotlin? I haven't compared those two. I benchmarked them in Kotlin, just like other functions. Haven't compared that. I guess it should be slower in Java because there is no, it's not inline in Java. What? It might not be because it's also built in, so maybe there are some optimizations with that. So I haven't tried that. Sorry if I said something that is not correct. Sequence reading line by line CSV file from disk seems like I/O bottleneck. Yeah, okay. The problem that I wanted to present is the way how we do that in general. Does it make any difference between using sequence and not using if whole stream consists out of one operation? Yeah, not. So my point was that it does not make sense. So turning into a sequence, doing one operation, turning out of a sequence makes no sense because, I mean, if the terminal operation is different, it might make a little sense, but if the terminal operation is toList, it definitely makes no sense. toList aggregation is slower than the one made by most operations because it does not know the size of a list in advance, what is an additional cost. And of course, you know, transforming here and there is not helpful neither. You know, there are some wrap types. Sequence operations cannot be inline, so there are some additional costs with that. It only makes sense when you have more processing steps. Yeah. Since sequences are lazy and therefore more efficient than Kotlin, couldn't always use them under the hood for intermediate operations on iterables. So that's exactly, I answered that already, you know, so it only makes sense to use sequence on a certain cases, not in any case. However, of course, there was a discussion, you know, there were discussions. For instance, Java chose to only support lazy streams. But the advantage of a list is that when you have only one processing step, it's very convenient. You do not need to, you know, go from list into a sequence and do something, and from sequence into list, you just make map, and that's it. So I believe that's the main reason why, you know, lists are you know, used, because more often we need one processing step than multiples, I believe. Why do you have that many books on the table? Because I want to give them away. And that was the last question. Thank you again. And please, those who want, stay with me. Or those who have extra questions. I want book. See ya.